All right, everyone, this is Chapter 10, Section 3. This is on the theory of plate tectonics. Let's get started. All right, this is Theory of Plate Tectonics, Chapter 10, Section 3. Anything that's written in purple or pink needs to be taken down as notes. So if you look at this cover page picture, you can see the main plates that are located on Earth. Not too many, but they all play a crucial role in what the Earth looks like. So the plate tectonic theory states that Earth's plates move around on a special layer of the mantle. So above the mantle you have the crust. The mantle is of a liquid form, so the crust will slowly drift over a long period of time. If you look at the picture up on top, it shows you Pangea from about 200 to 300 million years ago. You can see they were all in one continent. Pangea just means one land. "65 million years ago, when the dinosaurs were around," which is the picture in the middle, you can see what we believe the continents looked like. Notice how South America and Africa are close to each other. They call it Gondwana land. And this is the reason why we find fossils on South America that are very similar to Africa. And then the picture on the bottom will show you the pictures today, and then the outline in black shows where we think the continents are going to be 50 million years from now. Notice how the Atlantic Ocean, again, is getting larger. The one continent that really surprises a lot of people is the movement of Australia. Australia seems to be moving up towards the north and west towards Japan and China. You could pause it here now. If not, we're going to move on to the next slide. The lithosphere is made of the crust in the upper mantle. This is what it looks like. It's the upper portion. What separates the lithosphere from the rest of the Earth is something called the asthenosphere. The asthenosphere is just a plastic-like layer where it's turning from a solid portion to a liquid portion. Now remember the four main layers of the Earth. We have the crust on top, that's what we are on. Then you have the largest layer, which is the mantle. Below it is the core, which is the outer portion, which is liquid, and then the solid core, which is the inner core. Okay, we're going to move on to the next slide. If you're not finished, you can pause here. We have three types of main plate boundaries. Our first one is called the divergent plate boundary. And this is where two plates are moving apart from each other. The most well-known divergent plate boundary is called the Mid-Atlantic Ridge. The Mid-Atlantic Ridge is where you have the North American plate separating from the Eurasian plate, or the African plate separating from the South American plate. The Atlantic Ocean, because of the divergent plate, is getting larger and larger over time. Okay, we're going to move on to the next slide. This is an example of a diverging plate. Africa is right here, and on the eastern portion of Africa, in Tanzania, Kenya, Ethiopia, and Somalia, it is eventually going to be separated by a divergent plate. It's actually being pulled apart, and the eastern portion of Africa is going to separate away, forming possibly a new ocean in millions of years from now. Our next type of plate boundary is called a convergent plate boundary. Here you have two plates that are colliding together. Now there's different types of plates that can collide together. You have the oceanic plates and you also have continental plates. When an oceanic plate collides with a continental plate, they call it a subduction zone. This is because the oceanic plate is a lot more dense than the continental plate. And what happens is the oceanic plate will go underneath the continental plate, forming a trench. When the oceanic plate gets down towards the mantle, it melts and becomes magma. The magma then is less dense than the surrounding crust and is forced back upwards, and this creates those volcanoes. So a subduction zone is when an oceanic plate is pushed down into the upper mantle. One of the most well-known trenches, called the Marianas Trench, located by Philippines, is made by these two plates, the oceanic plate and the continental plate. Okay, we're going to move on to the next slide. If you need to pause to finish writing, you can do it now. We do have three main types of convergent plates. The first one is when the oceanic plate collides with a less dense continental plate. This is when you get your volcanoes. Type number two is when two ocean plates collide. This is probably one of the rarest of the three forms. And your third one is when the continental plates collide. The picture behind the writing here is a picture of the Himalayan mountains. The Himalayan mountains are formed when two continental plates collide. You had the Indian plate that has been moving into the Eurasian plate, and what's happening is the Indian plate is pushing in and pushing these mountains upwards. The tallest mountain in the world, Mount Everest, gains a few inches every single year due to these plates colliding with each other. However, there's not much in the way of volcanoes that are located in this area because you don't have an oceanic plate. You have two continental plates. All right, we're going to move on to the next slide. If you need to pause, you can do it now. Our final type of boundary is called a transform boundary. This occurs when two plates slide past each other. The pictures on the left and right are the pictures of the San Andreas fault line. To the right side is where the North American plate is located. To the left side is where the Pacific plate is located. They're sliding past each other. This one is moving in this direction. The North American plate is moving down towards the south. So they are sliding past each other, and they do still create a little bit of mountains because they don't move through past each other easily. Sometimes they get caught. When they get caught and they build that tension and they snap, that's when earthquakes will occur. Okay, we're going to move to the next slide. So why does the crust move slowly over time? Well, this is the culprit right here. It's convection currents. Convection currents are thought to be the force behind plate tectonics, and the reason being is because there's a pretty big difference in temperature from the inside of the Earth, the inner core, all the way up to the surface of the Earth, where the crust is located. Because of that difference in temperature, you're going to get these currents that form. Heat, as we all know, rises. As heat goes up, it will begin to cool. And that hot magma will replace the cooler magma. When it gets cool enough, the magma will sink back down towards the core, and that whole cycle starts over again. This causes that convection current, and on top, where the crust is, where we're located, it will slowly move over time. All right, we're going to move on to the next slide. So diverging plates, what happens with diverging plates if you have land? Well, in some cases, it actually pulls the two land masses apart and upward. Eventually what happens is water will get into there and it will flood out that area where the valley or the trench area is located, and it will fill up with water and it could create an ocean. Right? They call this rift valleys or fault block mountains. picture on the right is a picture of the Great Rift Valley located in Africa. If you need to pause at this point, you can do it. So most of the Earth's mountains, volcanoes, and earthquakes occur at convergent plate boundaries. And depending on the type of convergent plate boundary you have, will determine whether you have a volcano or just a plain old mountain. Okay, I'm going to move on to the next slide. This is our final slide of the presentation. You don't have to write this down. Notice how it is in black. Just wanted to show you because it's pretty interesting. Hawaii is moving at a rate of 8.3 centimeters per year towards Japan. So it's a pretty quick rate that the Pacific Ocean is recycling itself back into the mantle. So eventually, over a period of millions and millions of years, if there isn't erosion or parts of Hawaii don't slide back into the ocean, Japan and Hawaii are going to be fairly close to each other. Also, the Atlantic Ocean is growing over time. Maryland is moving away from England at a rate of 1.7 centimeters per year. This means that the Atlantic Ocean is going to get larger and larger over time, probably taking over the Pacific Ocean for being the largest ocean in the world. All right, this brings us to the end of the PowerPoint for Chapter 10, Section 3. Please make sure you bring your notes to class on Monday. All right, have a great weekend, everyone.